The Drift by Sanford Lab, where our researchers answer your giant science questions in bite-sized videos. Submit your questions via direct message on Facebook, Instagram, and Twitter.
I'm Tim Kneafsey, a staff Earth scientist at Lawrence Berkeley National Laboratory. I'm also the principal investigator of the EGS Collab Project. Sometimes we call it the Sigma V project, and I'll tell you why in a little bit. I want to tell you a little bit about the EGS Collab Project. To make an enhanced geothermal system, or EGS, we need to be able to flow water from one well to another through hot rock, so the water can pick up heat from the deep subsurface rock. We either need to find fractures to flow the water or make these fractures. We call making the fractures stimulating the rock. This is different from the hydraulic fracturing you hear about in the oil and gas industry, because the oil and gas industry only needs to flow fluids to their wells, and we need to flow fluid between at least two different wells. The hydraulic fracturing community has shown they could create permeability in their reservoirs and has done a lot of fracturing, or fracking, but there's still many things we don't know. The EGS Collab project is supported by the U.S. Department of Energy. The project is really an EGS dream team of about 100 very talented individuals from 9 U.S. national laboratories, 7 universities, 2 commercial entities, and of course SURF. Our job is to perform stimulations under different conditions, measure the effects of our stimulations, and use and modify computer models to be able to simulate and predict the stimulations. The project has laboratory, field, and modeling components. I should tell you that Sigma V stands for Stimulation Investigations for Geothermal Modeling, Analysis, and Validation. But many engineers use the Greek symbol sigma and the subscript V to mean vertical stress. At SURF, we have access to deep rock, where we have appropriate Sigma V for enhanced geothermal systems, making it a good place to do our research. We are building 10-meter scale test sites a mile underground. These test sites are smaller and much cooler than what would be used in a geothermal reservoir. We're installing precision instrumentation in boreholes in the rock to make our measurements, performing stimulation tests in different boreholes, creating flow across the test bed, and performing flow tests between the wells. We're also using the best available computer modeling to predict the behavior and to analyze our results. We've completed a number of good tests on the 4850 level and have learned quite a bit. It's nice being able to do these tests at SURF because it has a great infrastructure and remarkable people to support our research. We're looking forward to building a new test site soon to stimulate rock under different conditions to provide more data for building confidence in our models.